Dr. Shelton Cooper here, all the way from London, here to talk to you today about quadratic equations. Now, the first thing you need to know is, what does quadratic mean? Well, when the x variable is squared, it is known to be quadratic, and it makes this chart on a graph. According to the world-renowned source Wikipedia, in mathematics, a quadratic equation is a univariate polynomial equation of the second degree. What?
What?
What in the bloody? Anyways, basically a quadratic equation is when the variable x is squared, and the equation is set in standard form, which looks like this: ax squared plus bx plus c. However, there may be some cases when the equation is not in standard form. For example, you could have ax squared plus bx equals c, in which case you would have to subtract the c from both sides, thus making it ax squared plus bx minus c. So you have to be particularly picky about how your equation looks before you can solve it. Now that you have mastered the basics of quadratics, we can now move on to part 2 of this lesson, the first steps in solving a quadratic equation. So for those of you who remember your elementary school days, these are called factor trees. And a factor tree is a representation of prime numbers from an original number. So here in our first example of 36, we have a factor tree. And with a factor tree, you want to start with the original number and have branches come off of that represent factors, or numbers that multiply together, to get you that original number of 36. And here we have 6 and 6. And once you take those factors, you want to break them down into more factors. Here we have 2 and 3. And you want to continue to break down the numbers until it cannot be factored anymore. So this is basically all of the factoring you will need to know. So now we'll move on to factoring with quadratic equations. Now that we're moving on from factoring numbers, I'm going to show you how to factor equations with this example. As you can see here, we have the expression x squared plus 7x plus 12, which is in standard form, luckily for us. With factoring this expression, you're going to have two expressions, as you see here in the parentheses, since there are two x's, or x squared. So looking at this problem, you're going to use, or I like to use best, the FOIL method. So here you have x plus 4 and x plus 3, and you're wondering how in the world did he get that? Here we have x plus 4 times x plus 3. And we got this by taking the first term, x squared, and splitting it in the parentheses, x and x. The next term you want to be multiplied to get the last term, but added to get the middle term. This is where factoring equations gets tricky. So really you have to think it out, and here we get the correct answer of x plus 4 times x plus 3. Now a way you can check this is by doing the FOIL method, which is first, outside, inside, and last. With the first step, we multiply the first terms, x and x, which gets you to x squared. Then you're going to multiply the outside terms, x and 3, which gets you 3x. Next, you'll multiply the inside terms, 4 and x, which turns out to be 4x. Last, you'll multiply the last terms, 3 and 4, which gets you 12. Ironically enough, this matches our original equation, so therefore is correct. Now if you'll notice, I haven't addressed why the equation is set to 0. This introduces us to part 3 of this lesson, solving the equation. So the first step is to set the equation to 0, which puts it in standard form. The next step would be to factor it out, which we've just done. Now after you factor it out, you're going to use the zero product rule, which states that if two expressions, x plus 4 and x plus 3, equal 0, then each expression by itself must equal 0. So then you set each expression to 0, so you get x plus 4 equals 0, and x plus 3 equals 0. After solving for x, you get x equals -4, and x equals -3. Remember, since this is a quadratic equation, you will have two answers.